Hi, welcome back. In the last video, we looked at properties of the parallelogram, and in this video, we're going to look at areas of parallelograms. So we've done areas of regular polygons, and we've done areas of triangles. Now we're going to look at parallelograms. The area of my parallelogram is going to be the base of the parallelogram times the height of the parallelogram. So a lot of times when you see the formula, you'll just see area equals BH, base times height. Okay? So my practice problems, my first one says find the area of the given parallelograms. So I know I have parallelograms, and I'm just going to look at the base and the height. Remember your height, this is important, the height is always perpendicular. That upside down T means perpendicular. If you don't know that, you need to learn it because we've said it so many times. But if you don't know that, you need to write the word perpendicular next to that symbol so that you can learn it. Always perpendicular to the base. Okay? So when I look here, I need to make sure that my base and my height reach each other at a 90-degree angle. So I do see a 90-degree angle here, which means my height and my base have to touch at that 90-degree angle. So the area here is going to be 6 times 5, which is the area equals 6 times 5 is 30. Now let's talk about units. I can see these are all meters. So this is really 6 meters times 5 meters. So meters times meters is meters squared. That square has no effect on that number. If you put the answer down and it looks like this, if you say the area equals 30 and then you go, oh, it's area, so squared, that is wrong. Okay, because 30 squared is 30 times 30, which is 30 times 30 is 900. Okay, and my answer here is not 900, my answer is 30. That square is just describing the shape of the meters. So for example, if it was feet, it would be saying that's how many tiles you would need, because right, each tile, a standard tile on our floor, especially here at school, is a 12 by 12, is a foot by a foot. So they're little square feet because they're squares that are a foot on each side. So that square cannot be written on the number. It only affects what the units say. Okay, so that's super important to remember when writing your units, is the square cannot be written on the number answer. It has to be written on the units. Okay? When we look at the next problem, I see a parallelogram, and I see my right angle, which means I can tell that this 2 must be the height. The base is still only the length of the parallelogram, even though we had to extend that base out to the side to see what the height was. That height, the base is only the 7.7. The height is the 2, because I could redraw that height in here so that I could see my height and my base at the same place. Okay, so we don't extend how long our base is, we just extend it so we can see where our height is. When I do the area, I'm going to multiply the base, 7.7 meters, times the height, 2 meters, and I'm going to end up with area equals, I'm going to do just the 7.7 times the 2, and I get an area of 15.4. And remember, if I put the square on the 15.4, that's essentially 237.16. That is not my answer. My answer is 15.4, and then I write meters, because meters times meters is meters squared. Again, the square is describing the type of meters. It's not affecting this number. Okay? All right. Let's look at a couple of mixed practice problems. The first one, write an equation that would allow you to find A and B. So I'm probably going to have to do more than one equation here to find A and B. I do have information about all my sides. And what do I know about the sides in a parallelogram? So again, we need to know that this is given WZYX, or let's see, WXYZ. We'll call it WXYZ. WXYZ is a parallelogram. Otherwise, we don't know for sure anything really about this figure if it's not a parallelogram. Okay? So what do I know about the sides in a parallelogram? The only thing I know as far as when I look at my properties, I've got diagonals, I've got angles, I've got angles. This is the only thing I know about sides. My opposite sides are both parallel and congruent. So my opposite sides are parallel, which doesn't really help me find what angles or what the A's and B's are because they're sides. But my opposite sides are congruent, which means I can set their measures equal. So if I wanted to find A, I could do 6A plus 4 equals A plus 14. These two things will be equal. 6A plus 4 will be equal to A plus 14. And I could have written that either way. I could have written this one first. Okay, that's my first equation. And then my second equation, when I want to find B, so I could use this one to find A. It didn't ask me to do that. It just said to write the equation. But I could subtract A. 5A plus 4 equals 14. Subtract 4. 5A equals 10. So I could find that A equals 2 when I divide by 5. But again, it didn't ask me to do that, so I don't have to do that. Right? It just asked me to write the equations. But I could solve and get A equal to 2. And then I could test that by plugging it in and do 2 plus 14 is 16. 2 times 6 is 12 plus 4 is 16. So both of those sides would be 16. It would be correct. But again, it just asked me to write the equation, so I was already done. My other equation would be these two equal each other. So 10b plus 1 is going to be equal to 9b plus 8. And again, it didn't ask me to solve, so I'm done there. These two are equal. I could solve. I could subtract my 9b and then add my 1 and get that b equals 9. But again, it just asked me to write the equation, so I'm done at that point. Okay? All right, the next one, find the area of the given parallelogram. Okay, so this one, it's real tempting to go area equals base times height. My base is 11, and meters, and my height is 5. But that's not my height, because that is not 90 degrees, right? This is a different length than this. My opposite sides are the same. So if this is 5, this is 5. My height is not 5. So I need to figure out how to figure out what that height in there is. But I see a 60-degree angle and a 90-degree angle and a right triangle. So I see this right triangle where my hypotenuse is 5. I have a 60-degree angle here, which means I have a 30-degree angle here. And I have a 30, 60, 90 right triangle where my hypotenuse is 5. My short leg is across from the 30 and my long leg is across from the 60. Now I have two options. I can use trig or I can use my special rights. If I know my special rights, it's going to go a little faster because I just use the pattern. My hypotenuse is twice my short leg, so my short leg here is 2.5. And my long leg is the 2.5, the short leg, times the square root of 3. So this height is 2.5 square root of 3. I could have used trig. I could have said I know this angle here is 60. So this is opposite and hypotenuse. So I could have done sine of 60 equals the opposite, that's what I'm trying to find, my height, over the hypotenuse, and I could have multiplied here. and done 5 times the sine of 60. Now, when I do that, if I try to do that in my calculator, I need to make sure I'm in degrees. I don't have my other calculator available to show on my screen because I'm using my document camera instead of my desktop to record. But if I do, let's see, tangent of 45, am I in degrees? I am in degrees, so it should work. I want to do 5 times the sine of 60. So 60, if I take the sine of that and I multiply it by 5, I get 4.330. And I'm also saying it's the same as 2.5 times the square root of 3. So if I do the square root of 3 and then the square root, and I said it's times 2.5, I got the same answer, 4.330. Okay, so you can use either method, trig, or if you remember your 30, 60, 90 rules, you can use your 30, 60, 90 rules. I like the 30, 60, 90 rules because I don't have to do this math. I can just go, oh, divide that by 2, stick a square root of 3 on it. And this is 2.5 square roots of 3 meters for my height. So then, I already have that part in my calculator. It's just 11 times this number. So I'm going to take this number and do times 11, and I get 47, my area, equals 47.631. There's no problem with decimals. Meters times meters is meters squared. And again, that squared cannot be written unless, let that focus, that square cannot be written unless it's on the units. If you write the square on the number, it's not correct. Okay? Make sure you write it on the units. Okay? When we come back in the last video, we're going to look at how to find the 4th corner in a parallelogram. And then we're going to find the area of that parallelogram once we get it graphed. All right? So come on back for that next video. I'll see you in the last one.